Hi everyone, my name is Ken Aguirre and now I'm going to talk about the Fostemsavir in adults with multidrug resistant in HIV-1. The definition of Fostemsavir is an investigational attachment inhibitor with an unique mechanism of action. It is a prodrug of Fostemsavir which binds to HIV.
Inhibitor. Proposed mechanism of action. Infection of a host cell by HIV leads to formation of new viral particles, death of the infected cells, and ultimately destruction of the host immune system. HIV particles carry GP120 proteins on their outer envelope, which play a vital role in allowing the virus to bind to host CD4 positive T cells. Attachment to the host cell represents the first step in viral entry and infection of the cell. This initial interaction between the virus and the cell, mediated by the viral GP120 protein, represents a novel target for antiretroviral drug development. HIV first binds to the cellular CD4 receptor present on the surface of the host cell. CD4 binding is mediated by the HIV GP120 surface glycoprotein, which together with the transmembrane glycoprotein GP41 forms GP160, which is present as a trimer complex on the viral envelope. In order to enable CD4 binding, GP120 must undergo a series of internal structural rearrangements. This process begins with rearrangement of the so-called inner and outer domains of HIV GP120. GP120 then undergoes further internal rearrangements in the region surrounding the CD4 binding site, which enable it to adopt a CD4 binding competent state. Once in the CD4 binding competent state, GP120 can bind to the CD4 cell. Following binding to CD4, GP120 undergoes further folding, which leads to exposure of its co-receptor binding site. Exposure of the GP120 co-receptor binding site enables engagement of the chemokine CCR5 or CXCR4 co-receptors. Following co-receptor binding, additional structural alterations expose GP41, which inserts into the host cell membrane. This initiates a series of major structural changes in GP41 that bring the viral and host cell membranes together, resulting in membrane fusion and release of the viral core into the host cell cytoplasm. This is where viral replication starts. The conformational changes that GP120 undergoes are critical in order for the virus to bind to and enter the CD4 cell. Attachment inhibitors represent a novel class of antiretroviral drug. They prevent the initial interaction between the virus and host cell, blocking subsequent viral entry into the cell. The attachment inhibitor binds to the outer domain of HIV-1 GP120 on the viral envelope, just underneath the region for CD4 binding. Once the attachment inhibitor is bound to GP120, the region surrounding the CD4 binding site can no longer rearrange into a CD4 binding competent state. As GP120 is not able to bind to the CD4 cell, subsequent viral entry is blocked. In summary, attachment inhibitors prevent the first step of viral cell entry, attachment to the CD4 cell membrane. This is in contrast to current entry inhibitors, which act after initial binding of the virus to CD4.
Application in medicine. Fostemsavir has a novel mechanism of action with no in vitro cross-resistance to currently available class and antiretroviral drugs, has a favorable drug interaction profile, and has shown both immunologic and virologic responses.
In your practice, what proportion of patients require targeting HIV by a drug that works by a different mechanism than those that are currently available?
Yeah, so this used to be a big issue. People with multi-drug resistant virus, lots of transmitted resistance, lots of cross-resistance within classes, much less of an issue. And most of them are the ones Joe was talking about, the people we started on treatment 20 years ago, the transmitted resistance from vertical transmission. So there's a subset of them. They're pretty rare. Even in an inner city population like mine, they're pretty rare because most of the failures aren't taking their drugs at all.
We have one patient who's in the iblizumab Fostemsavir clinical program.
But they exist. But they exist, and we, I think, are very pleased when companies are willing to go out there and try to create new drugs for a niche population who's in great need. It's a big challenge, right? Because they're unequivocally, it is a need, right?
Yeah,
but it's a small need.
A niche.
And so really the challenge is to both the FDA and the developers, how do you create studies that, where you want to study 300 people and each center has one person. You have to have 300 centers, and that costs a lot of money to do that sort of thing. And again, in the early 2000s, the people who failed with lots of drug resistance were actually our very adherent people that somehow stayed alive when they took AZT and then D4T, then Indinavir, and they stayed alive. So some of those studies, like the benchmark study and the power study, patients actually did really well because they were really adherent people.
Okay.
Even though they had lots of resistance, they had lots of resistance because they were adherent. Now it's the other way around.
Pros and cons. The minor serious and adverse effects reported in the BRIDGE study are a reflection of the advanced state of disease in the study population. Cons. The most common side effects were headache, rash, and urgency. In the most cases,
So we understand that when persons get incarcerated, a lot of these individuals do not get connected to care. And if you don't find them while they're incarcerated and help them overcome some of the challenges or allow them the opportunity to tell you what those challenges are, so you might be able to start developing a plan of care to address socioeconomic barriers that they're experiencing, or some of the things that are getting them in jail to begin with, such as substance use disorder or mental health disorder. Having that connection while in jail is huge, and we really found that that connection, while established in jail, allowed them to look for that individual when they got out. So that connection was really important, and the staff found that they had a lot of connections to the patients, or not patients at the time, but persons that were incarcerated, and they followed up and they came to the clinic when they got released. And it allowed them the opportunity to get some of the resources that they needed to connect to care, maybe address homelessness. We connected them with our non-medical case management care coordinators, clinical service representatives, and they actually worked with the state of New Jersey to help find housing for some individuals once they got incarcerated and got out. We worked with our emergency department. Many of these individuals end up in the emergency department if they get released in the middle of the night. And we established a process for those that didn't have a place to go, because that's where they ended up, in the emergency department, and direct connection from the ED to a housing collaborative partner. So that worked really well, and we found that we enrolled 85, the team was very successful. They enrolled 85 persons that were incarcerated. 75 of them, I believe, were connected to care, and I believe 50 of them remained connected to care, which is just outstanding. And even though they may not have stayed in care, they know that this is a resource for them, and they come back. So we might not see them right away, but eventually they do come back into the clinic, and they look for the girls that they met when they were in the jail. And
issue applied in Ecuador. 59% of adults and 52% of children living with HIV has access to antiretroviral treatment. In 2017, 21.7 million people living with HIV had access to antiretroviral treatment, which corresponds to an increase of Conclusion. In patients with multidrug resistant infection with limited therapeutic option, those who receive Fostemsavir has a significantly greater decrease in the HIV RNA level than those who receive placebo during first 8 days.
There are a number of ways whereby HIV can penetrate through blood vessels to reach its target population. It shows two different entities, both HIV and its main target cell, which is the CD4 lymphocyte. The virus has an outer layer, and the outer layer, as you see, contains a number of spikes. These spikes include the major glycoproteins of the virus that are responsible for direct interaction with the cell surface. You can also see the matrix core, which exists in the symmetrical shape of an icosahedron. You can see that structure of HIV is very, very complex. There is a lipid membrane, and from that lipid membrane you can see that the spikes protrude outward These include the surface glycoprotein, which is GP120, as well as a transmembrane glycoprotein that is termed GP41. The matrix core, the capsid protein, and the nucleocapsid protein all underlie the outer layer of the virus. And finally, in the inner core, you see that there are 2 strands of viral RNA, which are associated with 3 of the enzymes that are essential for virus replication. These are the integrase, the protease, and the reverse transcriptase. This attachment